Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good afternoon, welcome. My name is Kevin Schofield. I'm here to introduce and welcome Nicholas Christakis and James Fowler, who are visiting us as part of the Microsoft Research Visiting Speaker Series. They're here today to discuss Connected, the surprising power of our social networks and how they shape our lives. In Connected, the authors explain why emotions are contagious, how health behaviors spread, why the rich get richer, even how we find and choose our partners. Nicholas Christakis, both MD and PhD, is a professor of Harvard University with joint appointments in the departments of healthcare policy, sociology, and medicine, and in 2009 was named one of Times Magazine's 100 most influential people in the world. James Fowler, PhD, is an associate professor at the University of California, San Diego, in the Department of Political Science and the Center for Wireless and Population Health Systems. Christakis and Fowler's research has appeared on NPR's Science Friday, the New York Times, Washington Post, and USA Today, as well as the Oprah Winfrey Show, Good Morning America, Today, and the Colbert Report. So please join me in welcoming Nicholas Christakis and James Fowler to Microsoft to discuss Connected, the surprising power of our social networks and how they shape our lives.
Yeah, thank you very much for that introduction. When most people hear that we're going to be talking about social networks, they of course think about the online variety, which of course are a very recent phenomenon historically. And what James and I are interested in, although we will be speaking a not trivial amount of time about online networks, is a more fundamental reality that human beings have been embedded in social networks of very tremendous and very specific complexity since time immemorial, since we emerged from the African savannah. And social networks, in fact, are such intricate things of beauty, and they're so elaborate and so complex and so ubiquitous, in fact, that they beg a certain set of questions. What purpose do they serve? How do they form? How do they work? What do they mean for our lives? What does it mean for us as individuals? What does it mean for us as collectivities that we are embedded in these networks that have very particular kinds of rules that govern their form and their function? Now, James and I have been obsessed with this topic together for 7 years, but even before that, we were each engaged. And before we started collaborating 7 years ago, we were studying two problems which in a minute should seem related to you, but which may seem unrelated. I was interested in the widower effect, or the problem of dying of a broken heart, which is a classic problem in epidemiology and in demography. And James was interested in the problem of voting. Why do people vote? And what would these two, which is a classic problem in political science. And in my work, I had been looking at how it is that illness or death in one person might cause illness or death in another. So if I die, how does my wife's risk of death go up? How and why? And if you think about it, that's a very simple dyadic network. And I was interested in how some health-related phenomenon in me might spread and cause some health-related phenomenon in my partner. And I had spent quite a bit of time studying this, and at some point in the mid-1990s, I began to be interested in the possibility that it wasn't just dyadic effects that could happen, but hyperdyadic effects, because all these little dyads could agglomerate to form larger structures, such that if my wife died, it affects me, then I affect my brother affects his coworker, and you can have these spreading processes on networks. And this is where I was in 2002, where I gave a talk at Harvard and was heard by a colleague of ours who introduced me to James.
Yeah, so that colleague is Gary King. He turned out to be my advisor. I was a political science graduate student at the time working on the question of why do people vote? If you think about the election in 2000 between Al Gore and Bush, what we saw was that it was the closest election in our history. And so there was a sense that every vote counted. But if you think about those 700 people in Florida who decided the outcome of the election, try to think about what would have happened if any one of those people decided not to vote. How would the outcome have been different? Well, the outcome wouldn't have been different. And if the outcome wouldn't have been different, then from the point of view of individual choice, why does anyone ever vote? And so I was struggling with this problem the way political scientists have for hundreds of years. And I drifted to sleep, and then I had a pop culture moment, remembering that Breck shampoo commercial from the 1970s, where a woman becomes so enthralled with her shampoo that she decides to tell two friends, and the screen splits into two. And then each of them tell two friends, and the screen splits into four, and so on, and so on, and so on. And pretty soon, a bunch of women are all using Breck shampoo. And it occurred to me that One of the reasons why political scientists have had such a hard time with this question of why we vote is because they've thought about this question as though we are islands. We are Robinson Crusoe and not influenced by the other people. And so I began to think about what would happen if voting spread in networks from person to person to person. And that's when Gary King, when he heard Nicholas give his talk about the problem that he was trying to think about, he told me, you guys are thinking about the same problem. You guys really need to get together.
Yeah, and so in fact, one of the examples that we give in the book, and one of the things we talk about in the book, is that these social networks function efficiently in the background, these social networks in which we're embedded, to foster all kinds of collaborative unions, not just between co-authors, because we began as friends of friends, but as we talk about in the book, for instance, between partners. And one of the very deep functions we think of networks is, in fact, to function to find people partners. In fact, one of the arguments we make in the book is that if you're single right now, there's a 70% chance you're going to wind up marrying a friend or a friend of a friend or a friend of a friend of a friend. Just like some pathogen that's infecting your friend's friend right now is winding its way inexorably to you, even though you don't know it and you're well at the moment. There is a person out there who is your intended, who you're unaware of right now, but you will inexorably meet. And we talk a little bit about, we use this example to motivate a whole class of phenomena that we examine in networks. And in fact, James and I believe, are much more productive having been introduced than either of us would have been separately. And in fact, the whole has come to be greater than the sum of its parts, which is another theme we're going to be engaging today. So we're going to have a sequence of things we're going to talk about, and we're going to kind of take turns. We're going to open with some remarks on purpose-driven networks, so artificially designed or deliberately designed networks. We're going to talk about some canonical examples. Then we're going to segue and talk about natural human networks, which have a rather different topology and a rather different function. By topology, I mean architecture or structure of the ties. And then we're going to talk about some of our work on the role of evolution, because invariably or inevitably, James and I became interested in some of the genetic rules that govern the structure of human social networks. I should say there are technological, biological, psychological, social, and genetic kinds of processes that guide the structure of networks, all of which we discuss in the book. And then we're going to make a bunch of remarks. This will actually be sort of at least a third or half of the talk on our hyper-connected world and the ways in which online networks are the same but different than offline networks. And finally, we'll close with some bigger remarks, sort of opening up into some basic philosophical questions about how we think social networks are shaping our lives.
Right, so first of all, let's talk about networks that we form with a specific purpose in mind. Okay, so you guys are all sitting in rows here, and you can imagine there's a lot of heavy bricks on one side of the room, and we need to get those heavy bricks over to the other side of the room. Now, one possibility is that we all just run willy-nilly, and each of us go and grab a brick and trudge it all the way over to the other room, and we're running around like chickens with their heads cut off. Or we could organize ourselves in some way to make this process easier so that everyone can participate and do so in a way that minimizes the amount of energy that we spend. So what's one possible idea for how we do this? We could actually use what's called a bucket brigade. And this is the simplest kind of network, where here what we have is representations where each circle is a person or a node, and each line is a relationship. And the relationship here is who you're closest to in line. And so one of you can pick up the brick and hand it to the person next to you, and these bricks will flow in the direction of the other side of the room, which is where we want to get them. Now, if it's a regular bucket brigade where we have buckets, and we're getting water from a river to a burning house, for example, those buckets can actually flow back and forth in this very simple network. And what's interesting here is that your actions don't just influence the person that you're next to. They influence everyone up and down the line. They influence your friend. We can think of your friend in this person as the person next to you, but they also influence your friend's friends. You pass the bucket to the first person, and the first person passes the bucket to the second person. And as long as the line is, that's how many degrees of separation there are between all the people in this particular structure. Now, there's another kind of network structure that we use before the internet in order to get as much information as possible to as wide a group of people as possible. So say a school says they're going to close because there's snow, and you want to get this information out to a bunch of parents early in the morning so they don't drive their kids in. Well, one way that you can solve this problem is to assign someone to initiate an information cascade, where one person will call two other people, each of them will call two other people, each of them will call two other people, and so on. This is like the brick girl, right? This is every social marketer's dream, to find this central individual who's going to start using their product, and suddenly there'll be millions of people involved.
Actually, this structure
Oh, go ahead.
Yeah, actually, this structure could also be then turned on its head. I mean, we regard this as a canonical structure and used like in a Ponzi scheme. But now, instead of information flowing downstream, money flows up to the central individual. We should also mention that, for example, we could have shown you an image of 100 nodes and 99 ties. This image has 100 nodes and 99 ties. The same 100 people, same number of ties, totally different structure of the network optimized to fulfill a completely different function.
Right, and so one of the properties of this particular network is that it is a small world. What this means is that every node is connected to every other node by a small number of steps. And that's very different from the Bucket Brigade, where the first person is very, very distant from the last person in that line. But there are other kinds of networks that we utilize as well. We utilize densely interconnected groups of people whenever we want to accomplish something that requires a large amount of trust, where people know what to expect from the other people in their group. And so, for example, in the military, we typically train people in small groups where everybody is tightly connected to everybody else. And so, you would think, well, if this is such a good way to encourage trust, then why don't we all live in these dense networks all the time? Well, there's another kind of network that we are able to create, which is that what we want to do is we want to mix these densely interconnected groups of people with other groups that are densely interconnected, with some ties between the groups and some ties between other groups. And so this is work from Brian Uzi, who has thought deliberately about different kinds of organization that you would use in businesses to encourage creativity. And so specifically, in the production of Broadway musicals, what he was able to do is look at musicals like Pajama Game, West Side Story, Gypsy, and Fiddler on the Roof, and look at the individuals who created those musicals, and then see what happened after they created those musicals. Where did those teams go? And how did they mix with the other teams in order to create new musicals later on? And what he found was that there's this interesting trade-off. That yes, interconnected groups of people like the military squads, there tends to be higher trust in those groups, but because they all know what everybody else knows, they aren't getting any information from the outside world. And so there's this sweet spot, there's this Goldilocks point in terms of these networks being able to encourage creativity in the production of things like musicals and in the production of things like academic research. And so these are purpose-driven networks where we have thought deliberately, how are we going to structure these relationships to achieve a common goal? But what we have really been interested in addition to these purpose-driven networks, is natural social networks. So how is it that we come to choose the friends and relationships that we have in everyday life, and what does that mean in terms of how we influence other people?
Yeah, so we've been studying, James and I, for the last 7 years, a variety of networks, and our work initially began with something called the Framingham Heart Study Social Network, a network that we built using archival paper records that had not been used for research. We spent $1 million and 5 years of our lives and collected these documents from these archives and painstakingly reconstructed the social network. And what we were able to do was to situate about 5,000 people in a network of 12,000 individuals, and we were able to take repeated cuts of the network across time and watch the social relationships change across time, and also have information about the individuals within the network, so that we had all kinds of information about what their behaviors were, what their emotional state was, what their health was, and the like, and see how this changed in order to try to tease out what was happening in the network. Could we discern a set of spreading processes or not? Now, this shows what is known as the largest connected subcomponent of the Framingham Heart Study Social Network. There are 2,200 people shown here. And we have a variety of conventions on this slide that we're going to stick with for the rest of the talk. Every dot, of course, is a person. Every line represents a relationship. Here, the red perimeter dots are women and the blue perimeter dots are men. You can't really see that too well. But we're going to make dot size proportional to people's BMI. So bigger people get bigger dots. And then if you're properly obese, if your BMI is above 30, we're also going to color you yellow. Okay? So, and then the tie color indicates two different kinds of relationships. I forgot which is which right now, but orange is social relationships like a friend or a spouse, and purple, let's say, is a potentially biological relationship like sibling or parent-child. And if you squint at this network, and this was to our knowledge the first such picture that had been generated, you can see clusters of obese and non-obese individuals within the network. So just rendering the image and looking at it, and of course the Cartesian space here is arbitrary, right? This is a topological structure, this network, and it's been collapsed in 2 degrees and flattened. But if you just look at this network, you can see a kind of clusters of obese and non-obese individuals within the network. And this, of course, begs a certain set of questions. We used a bunch of fancy mathematics, which we can talk about. Either you can interrupt us or we can talk at the end. We're kind of on a roll right now, so I'll keep going. We used a bunch of fancy mathematics to document that the existence of the clusters was more than would be expected due to chance. We also were able to use these kinds of permutation tests to document that the radius of these clusters was 3 degrees. So my obesity status was related to the obesity status of my friends' friends, and my friends' friends, and then it stopped at 3 degrees of separation. Okay? So something about me was related to something about these other people who I don't even know, who are 3 degrees removed from me. But a bunch of questions are raised by such clustering, not just whether it exists and how big are the clusters, but also what causes the clustering. And one can imagine a variety of possibilities. The first, of course, is the false positive, that it's just random that it happened. We've excluded that by some of the statistics I just alluded to. Another possibility, of course, is homophily, or birds of a feather flock together. So if we find individuals within the network who are connected to each other, who share similar attributes, this is a well-known property of human social systems. Educated people hang out with educated people. Tall people hang out with tall people. Overweight people might hang out with overweight people. People who tend to exercise might hang out with other people who exercise. There's nothing special about that, although actually one can problematize that and begin to investigate or consider why. Why would human beings do this at a very deep level, which we are actually doing. But for now, this is a nuisance for us because we're not interested so much in understanding the property of homophily, like did I form my tie with James because I resembled him? Another possibility is contextual effects. So here the argument is that it's not that I form my tie with James because we share a similar body type, nor that my body type is influencing his body type, but rather that we both share an exposure to some third factor, like a McDonald's opens up nearby and makes me gain weight and makes him gain weight, and it's not my weight gain that's causing his weight gain. And actually in the widower effect, even 150 years ago when people were publishing on this, they recognized this as a problem because, for example, if I'm walking down the street with my wife and a bus hits and kills us, but me a few seconds after her, you wouldn't say that her death caused my death. It's this bus that killed us both, right? So it's the same kind of problem that, of course, obtains in this setting. And finally, and most interesting for present purposes, is this notion of influence, where my weight gain, let's say, might cause James's weight gain, which we call induction. But all of these things go by different names in different literatures. Now, this was one of the innovations we were able to make because we had longitudinal information in the network. We were able to try to look at sequential events in the network, which helps bolster our confidence that something causal is going on, that my weight gain is causing his weight gain. And this is a little video I'm going to show you, which was both the most exciting and most depressing moment of mine, I know his too, scientific career. Because we had literally spat blood to get this grant, to collect the data, to get the software to work, to make this video animation I'm about to show you to work. And we stood there looking at it, just desperate to see the following thing. Because in our mind's eye, when we had begun this project, our image was that this social network could be understood as a sort of hyperdimensional surface. And that what we would see is that we would see, like if you dropped a pebble on the pond and you disturbed the surface, that you'd see like patient zero of the obesity epidemic. Like I would gain weight, and it would make my friends gain weight, and their friends gain weight, and their friends' friends gain weight, and this wave of obesity would spread out on the network. And so our fantasy was that if we could actually get this thing to work, we would see this wave of obesity spreading in this network after accounting for the change in the network as it itself evolved across time. So the convention here is the same as before. Every dot's a person. Bigger dots are bigger people. If your BMI is above 30, we also are going to color you yellow. Red perimeter dots are women. Blue perimeter dots are men. Here we only show non-genetic ties. So the gray ties represent spousal relationships. Here's a woman married to this man in gray. And the purple ties represent friendship relationships, people who are friends with each other. So any two people connected here who have similar body size, it's not because they share genes. It's because they've actually formed a social relationship with each other. In a minute, we're going to start in 1971. We're going to take daily cuts through the network for 32 years. And you're going to see a sea of yellow emerge. The dots are going to get bigger and smaller as they gain and lose weight. The network is going to change topology. Ties are going to form and break. People are going to be born and die. Some dots will disappear. Some dots will appear. Actually, they don't appear in this image. And I want you to tell me whether or not you see this wave of obesity, this sort of epidemic spreading in the population. There's a woman right here who's going to gain a lot of weight in a moment. And then she's going to move to the center of the network. There she goes. And then at the end, you're going to see some clusters of obese and non-obese. A lot of complexity here, right, as this thing changes across time. And you'll see a cluster of obese and non-obese, for instance, individuals form right here, coalesce. And now we're up to 2002 and a half, and it stopped. Okay, so did you see this wave of obesity or not? We didn't see it. We were so depressed. I mean, we literally were. I was just like, I can't believe it's not there. You know, it's got to be there. I can't believe it. I can't believe it. We were so depressed. And it took us 24 hours before we figured out why it wasn't there. But in a group this size and this smart, there's usually someone right away who figures out why we didn't see this wave of obesity in this situation.
No pressure.
No pressure, exactly. Any ideas as to why? Well, yeah?
Well, two things. I mean, one, the image that you had, I mean, the topology was changing all the time. It was very hard to see anything spread out when you've got nodes moving around.
True enough.
And they're not in the same places. The second thing is you mentioned at the beginning that you've only got 3 degrees out relationship with others, which would mean that potentially these kind of waves wouldn't propagate in that fashion if they even existed in the network.
Okay, those are both very good points. The first point, we optimize the image to minimize the motion anyway, and it's about as good as you can get, although I take your general point. The second thing is we're going to come to this like 3-degree thing, and one way to think about it is a loose spring versus a tethered spring, another physics example. So, you know, you have the spring that you wave like the slinky on the floor that's untethered. You guys must remember this from college physics, or the slinky on the floor that's tethered. And actually, whether you get a standing wave or not has a lot to do with that, and we can talk about that. But anyway, so no, actually the reason is that obesity is not a unicentric epidemic. It's a multicentric epidemic. And the proper analogy is not a single pebble being dropped on the surface of a still pond. Rather, it's a whole handful of rocks being thrown on the surface of a still pond. So every individual pebble still causes this little dispersion, these waves that spread out, which incidentally could reach the perimeter, come back, and cause interference. So you get standing waves on the surface. But also, there's so many that you get a choppy surface. But it doesn't mean that a single pebble isn't causing a disturbance. It means you need a different set of techniques in order to uncover this than you would otherwise. So we resorted to a variety of other ideas to identify this. Yeah?
Did people influence larger people? Did you find that, or were you just looking at it from the point of view of...
No, thinness spreads and weight gain both spread. And why weight gain wins out has to do with another fundamental property of social networks, which is that networks tend to magnify whatever they are seeded with, but they need to be seeded. And so there's an exogenous force that's acting on the network that's causing people to gain weight, like changes in our society at large. We can discuss those. And that motive force is always there. It's like the hand dropping rocks. There's no wave on the surface until you drop a rock. And so that's why, on average, obesity wins out, even though both phenomena can spread. Yeah?
Are this the same group of people over the 30 years this week?
Yes, these are fixed.
Does this get normalized with the effect of aging on average obesity?
Yeah. Yes.
So I'm under the understanding that the main focus for obesity, the main driving point for obesity is reputedly increasing portion size of meals. So it's an environmental influence on individuals over that same period of time.
Yeah, but our work is not intended to suggest that this is the only cause of obesity, but rather that this is an additional factor, a magnification factor. And so the example we give in response to your question is, imagine an island in the middle of the Pacific with a population on which there's no epidemic until the sailor washes ashore and bringing with him a germ. Now this germ can spread in this network population. So some exogenous force comes and then the network takes over. And the architecture of that population on the island could have a lot to do with how it spread. Actually, I'm going to keep going right now. We'll come back to more questions. So one of the things we took advantage of, because we have some other cooler stuff that I think will animate more questions. So one of the things that we took advantage of was the directionality in the network in our effort to identify the effects that were here and try to make some claims about whether they were causal. And here's the way this argument works. So I could nominate James as my friend. And we're going to call that an ego-nominated friendship. It's not because we're from Harvard. It's just because that's a technical network term. So I'm going to say this is an ego-nominated friendship. Okay? Now James could reciprocate. James is my alter. He could reciprocate the nomination, and we'll call that a mutual friendship. We both nominate each other. And finally, James could say I'm his friend, but I might have no idea who the hell he is. Okay? This was my experience in high school. I thought all these people were my friends, and they had no idea who I was. Okay? So now, in which of those three circumstances do you think James's weight gain would be most likely to cause my weight gain? Mutual. We're very close friends. His weight gain is going to influence it. Second, which would you think?
He thinks you're his friend.
Other way around. I think he's my friend, the ego-nominated friendship. So I know James, I admire, I esteem him, I respect him, I'm following what he's doing. Things that he does will influence me. And last, if at all, the alter-nominated friendship. Because James says I'm his friend, he's gaining weight. I have no idea who the hell he is. I'm not watching his weight. I'm not interested in what he's doing. So I should be unaffected. And the reason this is crucial is that if it's the McDonald's opening up nearby that's causing me and James to gain weight simultaneously, it should not respect the directionality of the tie. The McDonald's doesn't care whether I nominate him or he nominates me. So if we find a patterning conditional on the directionality, it should bolster our confidence that something in him is what's causing something in me. And sure enough, that's what we find using a family of regression models, which I won't go into the details right now. We find that if an ego-perceived friend gains weight, it increases my risk of weight gain by 71%. If my mutual friend becomes obese, it almost triples my risk of obesity. An alter-perceived friend has an effect indistinguishable from zero. And we look across in the paper, there are more details. And in the book, we discuss this across a variety of other kinds of same-sex friends affect each other, opposite-sex friends do not. Same-sex siblings may have a bigger effect than opposite-sex siblings. Spouses, we look at immediate neighbors. We also look at coworkers. Coworkers at small workplaces affect each other, but not coworkers at large places. And we've looked at a variety of other phenomena, which as well, we've looked at smoking behavior, and we found this interesting thing with respect to smoking behavior, which is that whole groups of interconnected smokers who don't necessarily know each other quit synchronously at once, like they quit in droves. It's like a flock of birds changing direction, except now we're observing humans smoking instead of birds flying. So this interlocked set of people will suddenly go from one state to another out to about 3 degrees of separation. We've also begun to look at other things like emotional states.
Right, and so here what we wanted to do is rather than looking at health behaviors, we wanted to look at affective states and try to think about, okay, so it seems like people are copying each other's behaviors. What about their moods? So the very first thing that we looked at was happiness. And so here what we have is another network picture. What we have is each circle is going to be a person. The circles are women and the squares are men. And we colored them according to whether or not they were happy or not, psychological measurement of whether or not they were happy, standard used in the literature. And so the yellow nodes are happy, and the blue nodes are sad. Blue, get it? Okay, that's fine. And we also have different colors for the different ties. And so we've got red for friend and spouse ties and black for the sibling ties. And you'll notice here, much more strongly than you would notice in the other work, there's this clustering that goes on. Once again, we find that it goes out to 3 degrees of separation. And here what we find, contrary to the obesity results and to the smoking results, is that happiness and unhappiness tend to spread differentially. Now, Nicholas and I had a bet about this going into the analysis. Before we looked at it, Nicholas thought that unhappiness would spread more easily. And he was making the evolutionary argument that, well, if something is making me unhappy, it's probably something that's going to make me less likely to survive or to reproduce. I'll let you sort of think about what those scenarios might be. But he really had this idea that
bad news would spread fast.
Bad news, that's right. So, whereas I had this more optimistic appraisal of what might happen, and that is that one of the reasons why...
This is one of the few bets he won, by the way. That's why he insists on telling this story.
One of the reasons why you would expect happiness to spread is because happiness reinforces trust and reinforces cooperation in social networks. And cooperation, as we know, is one of the things that makes human beings different from other species. We cooperate with strangers in large-scale societies, much larger scale than any other species. And so when we broke it down, what we found was that, in fact, I was right, that happiness actually spreads more reliably than unhappiness. And what's interesting about this now is that it's consistent with something else that we find up here. I don't know whether you can see it or not, but the blue nodes actually tend to be more on the periphery of the network, and the yellow nodes tend to be more in the center. In other words, happy people are more likely to be in the center. And we can use the overtime information to show that when you become more central, you actually become happier. And the reason why this would be true is that if you have these happy waves and unhappy waves both spreading through the network, but happy waves are more reliable, then being at the center makes you more likely, on average, to catch more of these happy waves relative to the number of unhappy waves that you would catch. I'm sorry?
Which comes first?
What do you mean, the network or the...
Do happy people become central, or do central people become happy?
Central people become happier.
A vindication of another high school claim that you used to make, that if you would only be more popular, then you'd be happy. But you were right.
That's right. But we found it didn't work in reverse. So happy people tend to stay put. Right? And if you think about it, that sort of makes sense. Why should I bother trying to change my social relationships if I'm happy with the ones that I have now? And so this was yet another case where we found these network properties having a big effect on things that are really important to us every day.
Yeah, I mean, this was, to our knowledge, this was the first time such a picture had been drawn, looking at human emotions rendered in this kind of network sense. There's been a bunch of work that's by us and others since then looking at these kinds of things. And this began to raise for us a deeper set of questions about what might be some of the biological and genetic precursors of some of these phenomena. For example, one of the basic questions here is, when human beings have emotions, we show them. Why do we show our emotions? Why do others copy our emotions? This begs a certain set of fundamental evolutionary questions, which we then engaged in another set of projects. But before getting to that, we kind of tried to synthesize some of the work that we've done on the 3 degrees of influence. So while we believe that there's been nice work by Duncan Watts looking at, with an email experiment, many of you might know, confirming the kind of 6 degrees of separation argument about human populations. While we might be connected on average to everyone else on the planet by 6 degrees of separation, we think we're only able to influence and are influenced by people up to 3 degrees of separation. So we've done work on obesity, smoking, happiness, loneliness. It's coming out soon. We didn't show you that. Drinking, depression, those papers are forthcoming. We have a nice set of experimental results on cooperation. If I'm nice to James, then he'll be nice to you, stranger to me, and then you'll be nice to her, stranger to both of us. So you can have a kind of pay-it-forward cascade we've shown with some nice experimental work. And other people have done work, for instance, piano teacher referrals tend to go about 3 degrees. The average piano teacher will find their students within 3 degrees removed from them. Or spread of inventor ideas. A typical inventor will cite or be aware of patents by other inventors who are within 3 degrees removed from them, net of the probability that the inventors are working in the same intellectual area. So the awareness, the information awareness, is also governed, it seems like, by this type of property. And we imagine, and we discuss in the book, we have 3 hypotheses about how this might work. One is picking up on the theme that we talked about earlier, this kind of pebble in a pond. There could be like an intrinsic decay, right? As the radius from the impact increases, the energy, the wave height declines, and the energy eventually dissipates due to friction. So one would be just intrinsic decay in the flow of information or other kinds of processes of influence. Another is what we call the network instability idea, and we've been doing some work on this area. Here the argument is like this. If you think about the people who are 1 degree removed, we can think about this like electron shells. So if you think about the people who are 1 degree removed from me, they're very tight. They don't change from moment to moment. And 2 degrees removed from me, they're a little less stable. So my friend to friend, I could lose the tie to that person because my friend dies or moves, or my tie to my friend gets severed, or my friend's tie to his friend gets severed. So the people 2 degrees removed from me aren't the same as much from time to time, even more so for 3 degrees. The argument is that at 4 degrees of separation, the people that are 4 degrees removed from you today are not the same people as the people that are 4 degrees removed from you in 2 days or in a month or in a year, because that shell is constantly changing around you. And so here the idea is you don't influence and are not influenced by people 3 degrees removed from you because they're not the same people. And our final argument picks up on some ideas by anthropologist Robin Dunbar, and probably most of you know about Dunbar's number. It's what we call the evolutionary purpose argument. Here again, picking up on some material we're going to talk about in just a moment, human beings evolved and emerged to be in nested network populations of about 150 to 300 people. And here the argument is we're not built to be sensitive to stimuli that have come from more than 3 degrees, nor to influence people that are more than 3 degrees, because 100,000 years ago, there was no one more than 3 degrees removed from us. The mean path length in a population like this might only be about 3 degrees. And so this is speculative, but we have some ideas about it. So this line of work on what might be the causes of 3 degrees of influence, and also on the emotional work that we've done, the work on emotional spread, has gotten us to thinking a little bit about the fundamental biological determinants of network structure. So here's another simple idea. Here's a sodium chloride crystal. You're all familiar with this. Ask yourself this question. All the pictures of networks that I've shown to you so far look nothing like this. They do not look like a regular lattice. But a human population could, in theory, look like this, look like a regular lattice, where every single person is connected to 8 other people, and all those people are connected to 8 other people, and every spot in the crystal is isomorphic to every other spot in the crystal. So everybody looks like everybody else. But that's not the case. human beings do not, in fact, form or live out their lives in regular lattices. Social networks have a very different and very particular kind of structure. And in fact, the striking patterns of human social networks and their ubiquity and their apparent purpose beg the question of whether we evolved to have them and have particular kinds of social networks and, in fact, have heterogeneity in our topological locations within social networks. So let me walk you through that for just a moment. And here's a typical network. This is actually a network of 105 students at an elite Northeastern university. Imagine now that you could choose to be individual B or individual D. What's the difference between B and D? B up there and D here. Well, B has 4 friends, and D has 6 friends. Okay? And so you can imagine circumstances in which it might be to your advantage or disadvantage to have more or less friends. For example, most people think it's better to have more friends. It makes your health better, it makes your emotional life better, and so forth. But it's also more burdensome to have more friends. You owe more debts, you have to care for all these people. And some of us are rather solitary. We don't like to have many friends, and other of us are gregarious, and we like to have many friends. There's heterogeneity in the population in B and D. Okay, now consider individuals C and D. They both have 6 friends, 6 ties. You can count them here, 1, 2, 3, 4, 5, 6. This picture's in the book. If you talk to C and D, they would each say that they had 6 friends. So from their perspective, their social worlds look the same. But of course, from our bird's eye view now, they occupy very different realities. And this point can be punched home by asking a simple thought experiment. Imagine a deadly pathogen were spreading through the network. Who would you rather be, C or D? D, right? You'd rather be D, of course. And it's obvious to you now, but if you talk to them, they wouldn't know, because C is going to be buffeted on all sides by this deadly pathogen. Now imagine that a valuable piece of information, or a salacious piece of gossip, not about you, was spreading through the network. Now who would you rather be? C, because this person is going to get information from all sides, right? So now we can imagine, we can begin to construct a kernel of an evolutionary argument where there's balanced selection pressures. There are advantages and disadvantages to being in the middle or in the periphery, net of your vertex degree, net of how many ties you have. Okay, let's look at A and B. What's the difference between A and B? What? Mutuality, or transitivity, we would say. So A has 4 friends, and B has 4 friends, but A's friends know each other, and B's friends do not. And here the argument is, if you were going to hunt a mastodon, who would you rather be, A or B? A. Let's get all my buddies together, let's go bring the damn thing down, we're going to kill it. All right? Now, on the other hand, if you want to find a mastodon, who would you rather be? B. Because in A's case, every one of my friends all has the same information. Do you know where the mastodon is? No. Do you know where the mastodon is? Everyone is going to be having access to the same information, just like the Brian Uzi story James told earlier about the shows. You want to have a mix of people who've worked together and who trust each other with people who bring fresh ideas into the group. So again, we can imagine constructing a situation in which there's balanced selection pressures on having both transitive and non-transitive groups. And in fact, this is what we looked at.
Yeah, so you might wonder, this is an interesting hypothesis, but how would you go about testing something like this? I mean, the claim that we're making is not just that there's differences in where people sit in these networks, but that our biology is in part responsible for these differences. So how would you go about testing this idea, other than getting blood from everybody and carefully working out people's genomes? Well, there's actually an easy trick that's been used by behavior geneticists for a very long time called the twin study. And what this does is it compares how similar identical twins are to how similar fraternal twins are. Identical twins share 100% of their genes. They had exactly the same variant of each one of their 25,000 or so genes. Fraternal twins are just like ordinary siblings. They get 50% of their genes from mom, 50% from dad, and so they share about 50% of their human segregating genes on average. Now, if you buy the assumption that these two different kinds of twins have similar environments in terms of how they act on networks, then what that means is that if the identical twins' network properties are more similar than the fraternal twins' network properties, then the only thing that could be causing that is the fact that they have more similar genes. And in fact, what we can do is we can very carefully work out not just that there's a significant difference between these two groups, but we can estimate how much of the difference in network structure can be attributed to the genes. We call this measure heritability. So the more heritable something is, the more the variation in a specific population can be accounted for by differences in people's genes. And when we applied this to the National Study of Longitudinal Health, this is a study of adolescents all around the country. It's nationally representative. We looked at about 1,000 twins. And when we did this, what we found was that there were 3 network properties in particular that were heritable. Okay, so the first one is in degree. This is just the number of people who name you as a friend. So not a surprise there, right, that popularity is going to be in part genetic. We have different amounts of face symmetry. We know that face symmetry is related to subjective perceptions of beauty, and that beauty is related to how many people are going to call you up for a date, right? And so this is nothing necessarily to shout to the rafters about. Transitivity, though, is also heritable, about the same amount. About half of the variation in transitivity can be explained by this. Now, remember, transitivity is this property that we talked about in the military group slide, where what that is a measure of how many of your friends know each other, like nodes A and B on the last slide. So the more of your friends know each other, the more transitive those relationships are. And so what we find here is that there's something really strange going on. Your genes are having an impact on whether or not 2 of your other friends are friends with each other. So your genes are influencing other people, not just yourself. And this has really important implications for the structure of these networks and where the structure comes from. There's a question in the back.
Did you take sex out of the equation?
Yes, absolutely. This is something that's standard to do in these twin studies.
So if you have Tom, Dick, and Harry in the room, whether Dick and Harry are friends with each other depends not just on Dick's genes and Harry's genes, but on Tom's genes. It's a really bizarre and fascinating result, actually. And
so to us, what this suggests is that selection isn't necessarily just operating on the individual. It's operating on whole structures of individuals. And if you take someone out of one network and put them in a situation where they're meeting new friends, what this suggests is that they'll have a tendency to have the same number of people who are naming them as friends, the same number of interconnections between those friends. And we also found that centrality, so how close to the center of the network you are, is also heritable to the tune of about 30%. And so what do we do with this information? This information that we're starting to collect about the biological basis of our everyday networks. Well, what we want to do is we want to start to think about how we take these networks online. And what we're finding is that there are some people who say that everything is going to be different, that the online social world is going to completely change the human experience. And we think that some things will change, but other things will not. And in the book, we go to great lengths to try to think about, in particular, what kinds of things will change and what won't. You know, things are going to be the same, but they're also going to be different. And so in particular, one of the first places that we've looked at to try and see what happens in these online social networks is a group of 1,700 students on Facebook in an elite Northeastern university that we can't name, but maybe you can guess. And so here's 105 of those, and this is their real-world social networks. Okay, this is their close friends, and this is just one of these dorms on this college campus that we were studying. So this looks very much like the other network structures that we've been showing you so far. But this isn't the only kind of relationship that people have. We have close friendships. We also have people who belong to the same ethnic clubs, right? So you show up once a week to some group and have a party and talk about issues that are important to you. And notice that it's not strict overlap. The friends aren't all part of the same ethnic clubs, and the ethnic club members aren't necessarily all friends. We also have roommates. And so, again, these are ties that don't necessarily coincide with either of those. I mean, I'm sure that many of you have had roommates that you weren't necessarily friends with, right? And so these
not
are
a good thing.
These are different kinds of relationships. And so far, these sets of relationships have looked like something manageable, something that we would understand from a natural point of view. But now let's see what happens when we add the Facebook relationships. It's not surprising, right? Because the average person, at the time we wrote the book, had about 110 Facebook friends, and now I'm almost positive the number is much higher. If you think about your own Facebook accounts, I'm sure many of you are going to have many more than that number, especially in a technology company like this. And this is just for one dorm. Let's look at the picture of everybody, all 1,700. It's a big plate of spaghetti. How in the world are we going to be able to make sense of this?
So you do the next enormity thing. Or you want to do it? Yeah, talk about the...
Okay. So one of the things that this makes very clear is that we are living in a sea of relationships, and a much more enormous set of relationships than we had before. And so these online social networks have gotten so big that people who are representing them, in many cases, are not even drawing the lines anymore, because it's just not possible to visualize those networks. And so just for example, this is a map of the Iranian blogosphere, where each node is a blog. The size of the node is going to be the number of inward links that they get from other Iranian bloggers. And they're placed on this network so that they're closest to other blogs that tend to mention them in their blogs. And what's interesting here is that you can get information whenever you drop the links just by their position in the space. And so just for example, we can see the reformist politicians are all over here. They're talking about how conservative the government is and how it's bad. And then we have conservative politics bloggers over here that are talking about how liberal the Iranian government is and how bad it is, which I was very surprised to find out that there's such a large group of those people in Iran. And you have representatives in the government, so Khatami, a recent president, and Ahmadinejad, the current president, who themselves have blogs, and these are connected to all these other people as well. But what this diagram really shows is that in politics, like in these other online social networks, you have these really complex and enormous networks that we're trying to start to make sense of. And so the question comes up, how do we go about analyzing our own data when we're looking at these 1,700 college students at this elite Northeastern University?
Yeah, so I mean, what this part of the argument that we're trying to make is that there's certain features of online interaction that are the same and others that are different, and that the fundamental reality of connection and contagion doesn't really change in the online world. Our interest in connecting with others and our interest in influencing and being influenced others doesn't change, but some aspects do change. And what James has just been highlighting, for example, is this vast set of connections. This was not present in the African savannah, right? We did not have this kind of social structure when we came out of the African savannah. But there is possibility of finding the signature of what we had within it. And so one of the tricks that he and I have exploited with the Facebook network is we've looked at what we call picture friends. So all of you may have Facebook accounts or MySpace accounts. You may have hundreds of friends. But if you look at the set of individuals who you post photographs of, it's a much reduced set. So what we found when we actually hand-coded these images, unfortunately, and we found that the average person had 110 Facebook friends, but they only posted on average the photographs of 6.5 other people on their own pages. And when we use that kind of data reduction, we're able to get a different set of ideas about what's happening. So we looked at all these people's pictures. Here now we draw the network, the Facebook network, where we draw ties only between people and their real friends, their picture friends, people who they actually bother to appear in a place with, take a photograph of, upload, and tag. And when you draw a picture like this, then we also took advantage of our ability to code the pictures, whether people are smiling or not smiling. So in a reprise of our Framingham happiness study, we kind of did the online analog. And the blue nodes are people that are frowning. I'm sorry, the yellow nodes are people that are smiling. And they have a little cluster over there. And that's sort of James's Facebook picture. And this was my Facebook picture until recently. And I'm not smiling. And you can see a cluster of people that aren't smiling in the Facebook network. Okay? So what you can see is a kind of, and it goes to 3 degrees. Whether people are smiling or not smiling in this online network, when you reduce it to the actual real ties, you see these kinds of phenomena. And so once we built the data set, then we started to play and do a variety of other investigations.
So you almost raised an interesting issue there for a second. The idea that you changed your Facebook picture to perhaps to a smiley one. Do you believe this will make your friends happier?
We don't have longitudinal data here to replicate our spread of happiness, but we think that it should work that way. But we have some other things that are spreading that James will tell you about now.
Right. So we can analyze not just these smiling pictures.
We only have statics on the smiles, but we have dynamics on other things.
Right, which means that we're not going to be able to tell whether it's the case that you're just choosing friends with similar profile pictures to be friends with. And so, God only knows how we got hooked together. So,
he's copying my blue shirt, however. I just want you to know.
That's right. I think it's spread to me. So. And so this is smiling, but we also were interested in some other things that we did have over time data for where we could look for contagion. And so we looked at, for example, the musical tastes. And so people are able to list what music groups they like on Facebook. And so this is an old way of looking at data whenever you go out and survey people. You just give a top 10 list. And so these are the top 10 music groups that people have listed over the last 4 years as we've done this study. Now, an interesting question to ask is, which of these musical tastes spread? and how do they spread? And because in that we might be able to get information about the kinds of things that people are doing whenever they're making these kinds of decisions. And so just for example, what we find in this case is that only 2 of these musical groups exhibit evidence of spread, the Beatles and the Killers. And in fact, now there's a very interesting difference in the way that they spread. Beatles fans tend to be widely dispersed in the network. And so they can be in the periphery, they can be in the center. You'll have groups of them that are tight, groups of them that are diffuse. Whereas the Killers fans, they've got their backs against the wall and against each other, and they've really circled the wagons into these tight groups of people who all liked this particular music group at the time. It's almost as though they've formed these identity cliques based on this particular kinds of music. And so what it suggests is that, I'll put Beatles on my web page because I think it's cool, but it's not necessarily going to cause me to identify with a specific group. We've also done this for movies. Okay, so once again, here are the top 10 movies that we found in our data on Facebook. And which of these do you think spread? Well, as it turns out, we found 3 of them spread: Pulp Fiction, Love Actually, and Good Will Hunting. And we found a particularly interesting difference between the Pulp Fiction fans and the Love Actually fans. And before I show the picture, I want you to ask a question. What part of the network do you think the Pulp Fiction fans sit in compared to the Love Actually fans? Well, as it turns out, the Pulp Fiction fans are in the center, and the Love Actually fans are on the edges. And again, another lesson for social marketers. You think you want to find the Breck girl, and you want the Breck girl to be in the center of the network because then everybody is going to love your product. But if your product was Love Actually, and you started hitting the center of the network, you would have failed. Because there are some things that don't just spread throughout the network. The structure of the network itself has an impact on what is going to spread and where it's going to spread. Now, an interesting contrast to both of these is the taste in books. And so here are the top 10 authors listed in our group of people on Facebook. And the ones here that spread are just 2, Salinger and Shakespeare. And what we found here was that there wasn't any consistent pattern.
We hope we spread too, by the way, but we're not sure about that.
Yeah, we might make it to the top 1,000.
But we don't resemble Salinger and Shakespeare, alas, so we don't know.
Yes, we're still alive.
Yes.
But we didn't find any kind of structure here. We didn't find center, periphery. We didn't find diffuse, internal, anything that would resemble some kind of group structure. That's the way we did for music and for movies. And the way we explain this is that books aren't really about shared identity. You don't sit down and read a book with somebody else. But you'll listen to music with somebody else, you go to the movies with somebody. Those activities are explicitly social activities, and so what we expect then is that these contagions are going to be more contained within groups and more structured than taste in books. And again, that suggests that there are going to be some things that you can target certain parts of the network for in terms of marketing, and some things that you're not going to be able to do the same kind of thing for. So now, enormity obviously is one way that the online world is different, but we also thought of 3 other things that are important besides enormity. One is communality. And the best example of our communal impulse and how that really gets magnified in these large networks is Wikipedia. So think about the Sarah Palin page during the last election. At its peak, it was getting 1,000 edits a day. And so you can imagine, Wikipedia is just like this blank wall with a bunch of spray cans that anyone can go up and spray anything they want on the wall. You would expect that the outcome of that process is just going to be a big Jackson Pollock, right? It's just going to be a big, although, Jackson Pollock probably, I don't want to offend any Jackson Pollock fans, but it's going to be something that doesn't have a lot of structure to it. But in fact, what we find on Wikipedia is that there are people who take responsibility for the outcome of a certain page. And they enforce POV, point of view, on Wikipedia. So that what you found during the election was that someone would come in and say something really, really positive and untrue about Sarah Palin, and it would get taken down. Another person would come up and say something really negative and untrue about Sarah Palin, and it would get taken down. And if you looked at any one point in time, the entry was actually remarkably balanced as a result of these altruistic efforts by people who are combined in this massive social network online. And so these communal resources really I think are going to be one way that we're going to be experiencing a different kind of life, one way that our natural social networks really don't necessarily function already. Specificity is another thing that's going to get amplified online. We already tend to look for people who are like us, right? But this is much easier to do online. And so, for example, this is a lovely map by Letta Adamic of the political blogosphere in the United States. And there was all of this talk about how the internet was going to democratize our discourse and allow us to have access to diverse points of view. And each one of these lines now is a link from one blog to another. You've got blue are the liberals and red are the conservatives. And how much discourse is going on here? These nodes are being placed near the ones that they tend to link. All the liberals are tending to link to all the liberals, and all the conservatives are tending to link to all the conservatives. And you have some links in between, but the vast majority of the links are to people who already have the same point of view. And so, on the one hand, this could be a really bad thing, right? Because it might accentuate the polarization, the political polarization, like we talk about in the book, that we've already experienced over the last 20 or 30 years. On the other hand, the ability to find people like you can be really helpful in terms of, say, finding a mate. Or if for example, you have a rare disease, you might be able to find someone else with that rare disease and get support from that person in a way that you wouldn't have been able to do before because you wouldn't have known that that person even existed. And we have some nice stories in the book about people who actually find these other people and are able to really get more information about how to treat the disease and also how to cope with the disease over time. And so this increasing specificity is going to be a double-edged sword as we take our natural social networks online. The last thing that's really different is this idea of virtuality. Okay, and so you might, for example, go on to Second Life and create a character like this, but in real life, you might look like this. Now, you might not only have different images, but you also might have different personalities online and offline. And one very interesting thing that we talk about in the book is that psychologists are actually starting to use this to study behavior. And so, for example, there was a recent experiment by Stanford psychologists in which people were asked to play a bargaining game. And in this bargaining game, what they did to people is they randomly assigned them avatars that were taller or shorter. And what they found was that online, that the people who are randomly assigned these tall avatars, they tend to ask for more in the negotiation, and the other person tended to give them more in the negotiation. So this is the first time psychologists have ever been able to do this. You know, psychologists can't walk up to you and say, I'm going to make you look like Chuck Norris now and see what happens to you, right? And so one really cool outcome about this is that social science will never, ever be the same. We're going to be able to do so much because it looks like we're able to actually manipulate people's behavior just by changing their identities online. But the other thing that's really important is that what this means is that we actually have different identities online, and they influence our behavior. It appears that we actually behave differently online than we do in real life. And so we think that we're going to be taking our natural social networks online, but we're also going to be creating these identities from scratch online that will have their own rules. And it's going to be very interesting to see, how these rules unfold in the coming years.
So I'm just going to close with a couple of remarks. We're going to close with a couple of remarks about sort of big picture ideas, and then we can take some questions. We got some unclear guides as to how long we have to go, but we'll just take a couple more minutes and then we'll do some questions. So I think one of the ways that we see the science of social networks advancing social science actually in philosophical thinking about human social systems in general is the following. If you think about sort of 18th century perspectives on understanding collective identity and group behavior, the imagination was that you had a series of isolated individuals, and the canonical example, of course, is Adam Smith, each individual acting in the furtherance of his or her own interests, as if by an invisible hand is guided to create, let's say, an efficient market, which is a collective property of the group, right? So you have individuals that are isolated, and you get a group by the virtue of actions of individuals. And partly in reaction to that, in the 19th century, you had scholars like Karl Marx and Emil Durkheim who said, no, really, to understand social systems, you need to understand groups as a whole. Forget about the individual. So you have the proletariat, you've got the bourgeoisie, you've got the nobility. Each of them can be understood as having their own identity, even their own consciousness, their own will. These groups act independent of the individuals. Emil Durkheim talks about suicide rates being constant in a given religion in France over 100 years, even though the individuals have come and gone. And this relates to a very old philosophical problem known as the family knife. The family knife problem is 100 years ago, your family had a knife, a very special knife. And then 90 years ago, the blade broke off and the blade was replaced. And then 80 years ago, the handle broke off and you get a new handle. And then 70 years ago, a new blade. And then 60 years ago, a new handle, up until the present day. And you still think of it as the same knife. This is our family knife. This is grandpa's axe, even though the handle and the head of the axe have been changed countless times. It has an identity that transcends the components. And so this is the same kind of argument that these scholars are making. These groups have an identity that transcends the component individuals. But then in the 20th century, there was a kind of an increased desire to study individuals as members of groups or as members of classes. So here the argument is each of these people might be black or white, rich or poor, and their membership in these groups then confers certain likelihood that they will act in a particular kind of a way. They have this kind of identity that influences their behavior. And in fact, a whole panoply of statistical and other conceptual methods were developed that took advantage of this, sort of ideas in game theory and in statistical estimation that exploited this basic perception. But we think in the 21st century there'll be a new way of understanding how individuals are nested within groups and how social systems come to be and act. And that is when we add the specific structural information of the ties between individuals. And that by adding the ties, we can begin to understand the emergence of groups, and we can begin to understand how it is that groups of individuals are greater than the sum of the parts. So we close the book with a set of arguments, which I'll just summarize right now, that we think speak to a set of philosophical questions that have been with us for hundreds of years. One is this question of the whole is great. How is it, in fact, that the whole comes to be greater than the sum of its parts? Where does this excess produce come from? And we think it comes specifically from the ties. If you can organize groups of individuals in particular kinds of ways, the pattern of organization has a lot to do with how that group is able to do more than the given individuals themselves who could be fixed from situation to situation. So we talked at the beginning about the Bucket Brigade and the telephone tree, two different ways of organizing the same 100 individuals able to do completely different things. That ability to do different things and that ability to do more than the individuals themselves arises because of the ties and of the pattern of the ties. A focus on networks also begs a certain set of questions on what we call a new kind of hierarchy. So the customary way we think about hierarchy in our society is that people have socioeconomic privilege, or positional privilege. They're rich or they're poor, they're well-educated or not, and we focus a lot on that. But we can also begin to understand people as having a structural hierarchy or structural privilege, whether you're in the middle or in the periphery of the network, for example, whether you have many or few links, whether your friends do or do not know each other. These are basic ideas. This might also confer on you advantages, so that if you're in the middle, you're more likely to get certain advantages that wouldn't otherwise accrue to you. And it begs a certain set of questions about free will. Because if it is the case that whether your weight or your smoking behavior, or frankly even whether you're happy, depends not just on your own choices and actions and behaviors and feelings, but also on the choices, actions, and behaviors of other individuals to whom you're connected, some of whom you do not even know, what does that mean about your ability to have free will? If you're just a bird or a buffalo stampeding and moving in one direction, then what is your agency? What is your ability to move the herd? But we turn the problem on its head a little bit and argue that while it may be the case that free will is attenuated by our embeddedness in social networks, it also means that we can, even as we're being influenced by others, take responsibility to influence others. And in fact, our actions can influence hundreds or sometimes even thousands of other people by virtue of what we do. And finally, we argue in the book that ultimately networks and goodness are deeply related. Because while it is the case that things like suicide, germs, violence, and misinformation can spread in networks, if it is the case that I only did violent things towards you or gave you bum steers, you would cut the ties to me and the network would disintegrate. The fact that we continue to live out embedded lives means that on balance, the spread of love and happiness and kindness and accurate information through the network sustains and nurtures the network, even while the network is providing a vehicle for the spread of such good things. Thank you. So we just want to acknowledge our network of...
We have to put this up here because these people worked hard.
Yes. So this is our network of people that helped us with the book, and then our funding agencies, and you can get more at connectedthebook.com if you're interested, including all kinds of extra links and slides and everything else. Yeah?
We're looking at the study. Did you do anything to quantify or assess what is the capacity for networks, and as that's changing from human-based interaction to social networks with communication advances, and sort of looking at capacity and stress versus happiness indicators? Because what we hear a lot is people constantly being overwhelmed by information in the networks, and what is the right balance point and what is the breaking point in those factors?
Right, so one of the things that we found, and I neglected to mention this, and it's a very important point, is that when we were looking at the spread of taste, for example, online, we started by looking at the Facebook friends. And Facebook friends don't influence you. It seems obvious, right? All these hundreds of people that a lot of whom you only barely know are not going to influence you. That's a central message from the Framingham studies as well. So, for example, if your next door neighbor gains weight, it has no impact on whether or not you'll gain weight. And so I think that people feel this stress, this information overload, and what is a reflection of is the fact that we have a natural capacity for a certain number of close relationships, and even a natural capacity for a certain number of indirect relationships. And what the online world is doing is it's pushing us in a direction that kind of forces us to ignore people beyond, say, Dunbar's number, beyond 150 people. So we pay attention to 6 to 10 close friends, we pay attention to about 150 friends of friends, or friends of friends of friends, or acquaintances, and then whenever more people demand our time, we go berserk. We just weren't built for that. And so I don't think that we're going to experience some kind of biological change anytime soon. And so it seems to me that the online services that are going to work the best are going to be the ones that understand that you need to be able to have things in place to be able to help people limit the information they see. So for example, Facebook just recently had a nice innovation where in your news feed, there's now a button where if someone, you see someone's status and they're only one of these people that you friended because you didn't have the heart not to friend them, right, but you don't really want to see them, you can click, I don't want to see this person in my news feed anymore. And after you do that for a week, suddenly you're back down to that core group of people that you really care about.
I mean, I would respond. So we blew by the kind of work that we've done looking at the influence processes in different categories. And this is where we make the argument in the book about it's the same but different, that on the one hand you have many more ties, but we're still wired to be influenced by only certain types of people, our real friends, not just our Facebook friends, we argue. The other point I'd like to make very briefly is the following, picking up on the military company example. So what's the size of a military company in the modern army? Does anyone know? About 120 would be the size of a military company. And what was the size of a military company in the Roman army? 100. About 100, yeah. Centurion ruled 100 guys. There were decurions, each 10 groups of 10 men, so you get 100 men. What's the change in the ability to communicate between individuals in those 2,000 years? Enormous. So we have radios and walkie-talkies and radars and internet and Facebook and all this stuff, and yet the fundamental working unit of the military hasn't changed in size in 2,000 years. And we think the argument is, and this is picking up on some ideas of Robin Dunbar, that it's not about the ability of individuals to communicate with each other that enlarges our social reach, because our brains are limited in their capacity to monitor individuals and monitor the number of ties between individuals. So of course the number of ties grows geometrically, frankly, with any kind of interaction. So, a group of 1,000 has 1,000 times 999 over 2 possible ties. A group of 100, you don't know the number. So we think that there are these fundamental intrinsic biological constraints, and it's illustrated by this example.
And just anecdotally, there's about 100 people here who we thanked for helping us with our book. And to make this picture, what we had to do is we had to go through every single one of every single pair and say, well, does this person know that person? And that was pretty easy for the people who were really close to us. But it got to the point, it got to the lower 50. Well, I don't know if this person's ever met that person before. And it really brought home the point that there's this social horizon beyond which we can't see. And even our friends, a lot of our friends, we're not sure if they're friends with each other.
Do you have any thoughts on, along the capacity line around the brain's capacity of taking large amounts of information? Just looking at your slide here, the ideas around conceptual maps, mind maps, in terms of how the brain perceives information, linear versus something like this, which is more radiant. Have you run across any of that information of mind mapping or conceptual mapping?
So I'm not very familiar with that. I do know that people, when people start seeing these maps, when they see the video, for example, a lot of people really click and really sort of see this idea that we propose in the book about human beings forming a superorganism. Right? And so, we live our lives where we only see the people that are close to us, and we're not even necessarily very sure how they're connected to each other. But here we've got a bird's eye view of this vast social network. It looks like kind of like an amoeba, and it really gives you this idea that we're connected in a way that I think we were never able to see before. So just anecdotally again, it seems to me that these representations may help us to change from this individual, independent-oriented thinking about human decision-making and behavior to a frame in which we're going to think more about the connections between people and how those influence decision making.
Are you asking whether some kind of information data reduction procedure simplifies communication? Is that your question? Like, for instance, if I form a map of a complex set of information, am I better able to transmit it?
Yeah, one example of that is what's called a mind map or a concept map, where information is actually controlled and
structured this way. So you show the relationship between ideas.
A radiant
yes.
structure as opposed to a linear.
I understand what you say now.
It's like
I can't see. The techniques used to generate and study those kinds of maps of ideas are similar to what we do, but there's no close. There's a methodologic relationship, but I don't see more of a relationship than that.
So your point about communality, there are papers. For example, by Fernando Villegas, talking about the fact that Wikipedia is not policed by vigilantes. It is a very certain strict structure imposed by the administrators. So it is an external structuring that makes it what it is, and not the spontaneously, evolving, self-controlling, self-correcting system.
How much do the administrators get paid?
They don't get paid anything, but it's not the same thing as being vigilantes. They are nominated as administrators. They get selected because they've been doing a good job on something else, maybe by making edits and so on.
Right, so that's a good point. I think our point is that it's voluntary, right? And so the Encyclopedia Britannica did not emerge as a consequence of people wanting something like that before the internet. And here we have a structure where it's very easy for a large number of people to voluntarily create structures.
I think the structuring is very important. It is voluntary is good, but structuring voluntary.
Yeah, I mean, there's some basic structure that Jimmy Wales, whatever, and imposed from the beginning. So our claim is not about that there's some kind of anarchical environment. It's anarchy, and you suddenly get spontaneous structure. But I think you also have to grant that there's very minimal, like a platform is created, and with conditional on that platform is our point, that you get these groups of volunteers that then create these knowledge emerges from these interactions and these altruistic impulses. So what we're highlighting is the altruistic impulses and the emergence of accurate information conditional on this platform. It would be like if you said, why do ants behave a particular way and make colonies? Well, they exist on the surface of the earth. There's some constraint that's prior to the ants behaving the way they do. But given that, they make anthills and they make, all kinds of other things. So we would analogize between that platform and the dirt that the ant finds, and then from which it makes its culture. Are we evading your question or answering it?
Quite sure. I'm not sure why you claim that communality is something that's emerging in social networks. I think there is certain aspects of voluntary activity, but I think there is the structuring that makes it what it is, and not other elements.
Okay, so maybe the communal impulse is necessary but not sufficient.
Yeah, or I would say when we highlighted enormity, communality, and so forth, our intention was not to suggest that these are novel properties of humans or human groups, but rather to suggest these are particular kinds of properties of the social interactions online, which would be hard, if not impossible, to find in the real world.
In natural social
networks.
networks.
In natural networks. That we couldn't collaborate with thousands or millions of other people 100 years ago or 1,000 years ago.
Part of my problem, I think, is with your structuring of a notion of a friend. It's like, for me, not all my Facebook friends are my friends. And for you to take this simplifying assumption of pictures is, I think, another extreme. I think, I, as a principal, never put any picture of anybody that I know, without...
So we would treat you as friendless. And at the rate you're going, you're going to be... Yeah.
I'm not too worried about that. I'm probably... that doesn't,
concern you.
But seriously, what I would look at is whom you have communicated with within Facebook.
We would love to do that, and
that's next.
That's
right?
next. Yeah.
So wall postings and status replies and things like that.
Person-to-person messages.
We totally agree, but
more powerful than a blanket posting to everyone saying, "Hey, come check this out."
We totally agree with that.
But at a first cut, we don't find contagion between the Facebook friends, and we do between the picture friends. And so I think what that means is that it's a muddy pool, but we are getting something out of that we aren't getting out of just including everybody that you're connected to online.
Can you expand on your commentary around the movie top 10 and the marketing and the center versus the periphery?
Right, so we found that Love Actually and Pulp Fiction both spread in our network. So that is, just to be clear, what that means is that if you posted Pulp Fiction on your Facebook page, then your picture friends were statistically much more likely in the next period to post it as well. So it spreads. But the interesting thing that we found was that the location of the contagion was at the center of the network for Pulp Fiction fans, and it was on the periphery of the network for Love Actually fans. And so the idea is that if you wanted to sell Love Actually, and you had in mind that all I need to do is get the most popular person in the network to like my movie, that might not have been so easy because we didn't find any evidence that the Love Actually fans who happened to be at the center of the network were actually influential. It was these fans on the periphery where the contagion seemed to be happening.
Okay, maybe one more.
Okay, one more. Okay.
If you're aware of any studies that look at this gets back to the overwhelm question, that looked at changes in network phenomena within individuals over time, like whether people sort of reach a certain level of interaction in social media, use Facebook as an example, and sustain it, or whether people enter it, get overwhelmed, remove themselves, and become more isolated than they might typically be because they need a recovery time, and then whether they re-engage. Is anybody looking at that?
You mean re-engage with people in real social networks?
Or step back into either to that Facebook environment or whatever the next Facebook will be, 5 years. I'm just curious as to how people are coping with these waves of new ways of interacting with each other.
Okay, so there's going to be variation, from person to person, but Barry Wellman has a nice set of papers that suggests that these online social networks are not a substitute for real-world relationships. They augment real-world relationships.
We talk about that in the book.
Yeah,
actually.
exactly. So I'm guessing, though, that there are some individuals that get so into the online world, and Second Life in particular, I can imagine there are people that really just want to live there. There are some individuals that probably do eschew their real-world social networks for a time, and then when they get tired of whether the online space that they're living in, when they get tired of that, then maybe they go back to them. But that's not what we find on average. And so an interesting thing going forward, especially because we're interested in looking at personalities and even genetic basis of some of these behaviors, is there some kind of interaction between these online environments and people's fundamental tendencies to be in a certain part of the network that might help to explain when people are going to treat the two of them as substitutes and when they're going to treat them as complements, as one helping the other to be better.
Demographic.
Right, possibly, but the underlying the demographics presumably is going to be personality characteristics and biological differences as well.
Thank you very much.
Thank you.